Hello, everybody, and welcome. My name is John Strand. I'm with Black Hills Information Security and Anti-Siphon Training. Today, I wanted to talk a little bit about how clouds are evil. Now, understand that there's a lot of people out there that are constantly complaining about the cloud being someone else's computer and cloud computing is this and that, and there's a lot of problems associated with it. But I want to kind of address some of those issues and concerns, and I want to kind of talk about some of the testing techniques and some of the things that we've done at Black Hills Information Security whenever it comes to actually testing the cloud. Because we are actually still a long ways away from developing a unified cloud testing methodology, something akin to what we do currently with like Active Directory. We're a long ways from that. So let's jump straight in. All right. So when we're looking at cloud computing, I've mentioned the joke about it being somebody else's computer, right? And we get into these conversations as far as what cloud computing actually is and what it does for organizations and how they actually use it quite often. And one of the problems that you run into with cloud computing is most vendors try to shape the conversation of defining what cloud computing is specifically around their core competencies. So if you're looking at Microsoft, you're looking at Google, you're looking at Amazon, they're all trying to define cloud computing in their own special ways. They kind of link to their marketing propaganda. But for the sake of this presentation, I'm going to keep it pretty simple. Cloud computing is pretty much anything that is not on site, but it can totally integrate with any of your on-site services that you may have in your organization. Now, the difficulty associated with this is it actually greatly increases the amount of complexity to your IT architectures. And ultimately, complexity is the enemy of computer security, as we're going to be talking about that in quite a bit of detail as we progress over the next 29 minutes or so. Now, in some ways, that complexity is reduced insofar as the complexity you have to manage, because your cloud providers are actually going to take front, point, and center on things like patching and updating their own services. In some situations, not all. And in some situations, when it comes to configurations, it's going to be more secure default out of the box in some situations. But with that, more default coming out secure and all that stuff, the complexity is still there. And it gives your developers and your systems administrators ample opportunity to shoot themselves in the foot and open up massive security vulnerabilities in your organizations in ways that traditionally are not identified clearly in an organizations as well. So remember, when we're talking about anything in security, complexity is ultimately the enemy of computer security whatsoever. So let me give you a cloud example that doesn't fit in a neat box of what people think of as cloud security. When we talk about cloud security, the vast majority of organizations and people out there think of the big three. They think of Google, Amazon, and Microsoft, right? Those are the big organizations that offer cloud security services, so that must be cloud security. But Kaseya is interesting because it actually is a cloud service. If you're not familiar, Kaseya is an RMM, remote management platform, where organizations like MSPs can use this to install Kaseya on their customer networks and manage the computers of multiple different companies on their behalf. This sounds like a good thing. And for the most part, it actually is. You have MSPs that can handle the day-to-day IT infrastructure and management, reduce the cost for smaller and medium-sized companies, and life is good. Right up into the point that Kaseya became a single point of failure, not just for the MSPs that are out there, but also a single point of failure for those MSP customers as well. Because what ultimately happened is the Kaseya breach happened. An attacker actually broke into a web-based vulnerability that Kaseya had been notified about months prior. Then they were able to gain access to Kaseya's customers. And then after they were able to gain access to Kaseya's customers, they were able to then gain access to the customer's customers, which is the MSP's customers, which were thousands of companies. So that is an example of cloud security. You have this service that is used across multiple different organizations, and it kind of becomes the single point of failure as well. So one of the things I like to talk about for this is, what is the reaction? Some insurance companies, because of the Kaseya breach, have actually started putting in riders in technical insurance documents for their customers saying, if you're using RMM tools like Kaseya, they're going to shut down your insurance policy. Now, that's a knee-jerk reaction, and it's a horrible knee-jerk reaction, but it kind of shows you kind of how the overall industry is reacting to these. Rather than looking at it as a systematic problem, they'll basically choose like 3 RMM tools and ban those RMM tools, meanwhile allowing a bunch of other RMM tools to continue to process and continue to run. So when we're looking at this, it really kind of begats us needing to have a conversation about what is the cloud? What constitutes as remote access into our organizations? What access do different vendors have to our various servers, services, and workstations? The Kaseya breach is actually very similar when you're looking at supply chain type attacks to SolarWinds. Now, SolarWinds, I wouldn't say is a cloud type attack, but it's similar to that supply chain vulnerability in SolarWinds, where the Russians were able to gain access to some source code, push out patches and updates that included their malware to thousands of SolarWinds customers. So the question that you have to ask yourself is, who has access to the inside of your network? How do you monitor that? How do you vet your vendors? If you don't, that's fine. You at least need to be aware of that fact. And if you do, you need to be aware that that's actually a very, very difficult thing to do for many organizations as well. Now, there's a number of things that aren't going to change. One of the things that happens in computer security, if you haven't been around for a long time, is there's this hype cycle that exists in computer security, where there's a bright, shiny object, a new vulnerability, a new technology, and immediately every vendor in the world tries to solve that problem and tries to build marketing propaganda around that. And they try to sell it in some type of way that this is so fundamentally different that it completely changes the landscape of computer security forever. That's not necessarily true. You see, if you're looking at the basics and fundamentals, they don't change. For whatever you're doing, whether you're dealing with containers, whether you're working with something like Docker, or you're working with Ansible, Puppet, Chef, aggressor scripts, any of those different things, you're always going to need to have some level of visibility on the network, because the network is the wire truth. What is actually happening on your network communications is something that should be built into everything, whether or not it's a desktop, whether or not it's a server on a DMZ, whether or not it is a container that exists in the cloud itself. There needs to be some type of visibility into what that network traffic is doing with that particular service as well. This is an absolute solid need for incident response functionality, not just troubleshooting from a network perspective, not just basically looking at it from a defense perspective in signatures and artificial intelligence and heuristics and all that crap to detect attacks. It's just something that we need every single day. So that does not change. We also need to make sure that security is actually baked in to every single component that we're actually utilizing. And there's a bunch of vendors out there that are trying to bring that security visibility to the cloud infrastructures that exist. But it's difficult because many of the cloud vendors like Microsoft, Google, and Amazon don't necessarily have the hooks that we need to be able to get the level of visibility that's required to be able to see what's going on in their networks. So when we're looking at these things, the key concepts, right? If we're looking at endpoints or SIM for logs coming off of your different microservices, network monitoring, sandboxing, internal segmentation, we need to say that there's multiple fields of overlapping visibility that exist for us defending our networks and our cloud services. This can be true for an endpoint. As I said, endpoint. We need to have network security monitoring. We need to have AV EDR. We need to have some SIM technology for the logs coming off of it. We need UEBA, and I screwed up, it's UBEA, but it's UEBA, User Entity Behavioral Analytics. You can rip out that endpoint and you could put in a cloud service. For that cloud service, there needs to be network security monitoring. There needs to be some level of detection on that service itself of attacks coming against it. We need to have some SIM functionality for the logs coming off of that service. And yes, with those logs, there needs to be some level of heuristics to look for things like impossible logons from the one user account from multiple different locations, or password spraying or authentication spraying attacks or crawling attacks. You can use these overlapping fields of visibility for existing IT infrastructure components, and you can apply it to the cloud. Don't let anyone ever tell you that the cloud is so fundamentally different that we can start ignoring steps of computer security and some of the due diligence components that we have done for years. So I want to give you some additional examples. So RDP, fun fact. Did you know that .rdp files are allowed through most all email filters that are out there? They are. So think of like I send you a Word document or an Excel spreadsheet, right? Many email filters will check for things like malicious macros inside of those documents. And that's good, right? Now, you can also send it encrypted through some of those email services, and it doesn't necessarily have the visibility. That's another conversation. But RDP files are similar to like Word documents, Excel spreadsheets, zip files, things of that nature. But if you double click them, it actually opens up a .rdp or remote desktop protocol session with a remote RDP server. So with our research at Black Hills Information Security by Mike Felch and Steve Reverse Shell on Twitter, what they discovered is that you can send a person a malicious .rdp file that when they click it, it connects to an RDP server. It automatically mounts bidirectional shares with that server onto the client. And then you can automatically download malware into auto start entry points on the victim's computer system. Now, how exactly does this apply to cloud computing? This applies to cloud computing because many of the email service filters that are out there today are becoming greatly centralized. You're looking at Microsoft. Microsoft is doing email filtering for millions of organizations out there. That becomes a consistent stamp of security and implementation of security across multiple different organizations. You could be running Proofpoint to check your email. Same thing. That technology is picked up and it's reused again and again and again. Many times that technology is utilizing cloud services to check these things. And that whole approach is good. Don't get me wrong. It is. Because trying to run your own email servers and run your own security from scratch, not bright. You shouldn't do that. But in giving that control up to a vendor, many vendors won't shut down default configurations unless the threat profile starts clipping at a certain level that it's interesting enough to them to shut it down as a default profile setting in their service that they're providing. So if you're looking at something like .rdp files, this particular attack, we're back to OneClick Compromise, folks. For us at Black Hills Information Security, it's about the equivalent of us sending you an executable and you double clicking the executable and us getting access to your environment. But it hasn't been used heavily by malicious actors, so it hasn't been shut down as a default setting. Also, many organizations share .rdp files between their systems administrators. So this is one of those vulnerabilities that I like because it's going to exist for an extended period of time. And yes, it absolutely does fit into the cloud security model as well. All right, so let's talk about S3 buckets. So if you remember, like a couple of years ago, there were tons of articles and tons of research, or I should do research, where security companies were crawling Amazon looking for S3 buckets, open S3 buckets. And they would find these open S3 buckets, which are like file shares on cloud service in Amazon because they got to rename it to something different. And they would find these files and they could download all the files. And then they would quickly run to Wired or some other, news source. And they would say, look at what we discovered. We found this systematic, massive vulnerability. And look at this company or this government organization. And it was all in the news and everyone freaked out about it. And eventually, Amazon fixed the glitch. Because now if you try to make your S3 bucket completely public, they throw a warning, they'll shut it down by default, basically telling you that's bad, you shouldn't do that. So problem solved. No. See, whenever you're looking at something like S3 buckets, and this gets into one of the problems of cloud computing, is you can have the same type of thing that exists between cloud providers, but every single cloud provider uses a different name for it. So they can trademark it. So Amazon calls it S3 buckets. And in Microsoft or at Azure, they have something called blobs. And blobs are very similar. They can be a container that stores data. And you can enable that blob or that storage blob in Azure so it can be public, so anyone can access that. So we're seeing a huge uptick in our testing at Black Hills Information Security, where we're seeing these publicly accessible blob storage components, very, very similar to what you saw with S3, that we can then gain access to that data that we shouldn't gain access to. Sometimes things like configuration files, backup files for web services. You'll see a number of different APIs that are using blobs for storage and moving things around. And yeah, if it's public, which is really easy to reduce security to zero and making it so developers don't have to worry about that stuff, we can take advantage of it. Unfortunately, it's a different name. So when people are like, oh, do you have S3 bucket vulnerabilities? People are like, no, we don't have that problem. We're a Microsoft shop. I'm a Dapper Dan man. Same vulnerability exists there as well. Just hasn't quite gotten the press yet. We can also see things where we can do a search for things like default endpoint S protocol, HTTPS, in places like GitHub or other code repositories. And we can look for these privacy keys or these account keys. Now, these are very similar to having clear text passwords for various APIs exposed to the open internet. And as you can see, we've got privacy passport, OFR blob storage. We can then see the account key associated with that so that we can gain access to those blobs with those keys. This is very similar to S3 credentials and keys as well. So same vulnerability starts to show up, but because every single vendor insists on calling things by wildly different names, it makes it more difficult to come up with a unified approach in identifying the attacks and identifying the defenses that need to be implemented in our organizations as well. Other vulnerabilities. So if we're looking at the same vulnerabilities as the last slide, the attack path is we're going to find storage account access keys. We're going to download everything we can. We're going to go through those files. We might find sensitive data. We may find credentials. We may find configuration files or actual full source code for different programs. And then we can do things like possibly upload malicious content and create a trigger with a web shell. So that S3 thing may be fixed. Once again, there are other variations that are out there as well. OAuth. This is probably one of my favorites because I love one-click compromises and I love vulnerabilities that are not quite forever days, but near forever days, where you have a vulnerability that's going to exist for a good long time. So this attack, just to be completely clear, does require some setup on the behalf of the attacker. It requires the attacker to set up a domain, which attackers do all the time. Many times it'll require the attacker to create a company and register that company with someplace like Microsoft as a company that's going to create OAuth applications. And that costs money. It's not something you can just simply stand up. And then you got to go through an approval process with Microsoft. Lucky for us, we can do that. We're a pen testing firm. Lucky for attackers, they can take over other companies that create OAuth apps and they can start creating malicious OAuth apps. So let me explain. What does this actually mean? So if you're looking at OAuth, if you go to some place like Dropbox or Box.com or DocHub or DocuSign, many of these different services that are file services or signing services, they give you the ability to authenticate with your Microsoft account or authenticate with your Google account. Some of them allow you to authenticate with your Facebook account. And when you authenticate, that app online gets access to some of your data in Microsoft or Google or Facebook or wherever. Now, many times the only thing it's doing is just validating your identity. It's merely using Microsoft or using Google to verify that you are who you say you are, rather than having you enter a user ID and a password and have that particular vendor store that password in their database. It's just easier to say we're going to use single sign-on with Office 365. So they do this through OAuth. Now, this really great company out of Europe, MDSec, has this really cool tool that they've released called the O365 Attack Toolkit. And if somebody clicks into a malicious web app online, it'll allow that app to gain access to their email. It'll allow them to send emails, interact with file shares, and download and file replacement as well. Now, our tool, we call it Back Orifice 365. I haven't released it publicly yet. And there's a number of reasons for that, but it's very similar, right? We can email search, we can look for subjects, we can get photo data, we can pull down their OneDrive files, we can pull down their profiles, we can get all the context data associated with the user that clicked that link. Now, what does it look like to the victim? Click the link, this pops up from Microsoft, not us. This isn't something that we spoofed. This is directly from Microsoft. And you can see that the name of the app was Michael Allen. He created an app called the Rhinos App. And in Rhinos App, it says it's unverified, but it says this particular app would like to have access to the data that you've given it access to. Notice it doesn't give you details on what you gave it access to. It just says, maintain access to data you have given it access to. Sign you in and read your profile. Sounds okay. And then read your calendar. All this doesn't sound that bad. But in the background, a lot more is actually going on. See, the permissions that the app shows you on this slide and the permissions that it actually grants the app are two wildly different things. You see, Microsoft doesn't want to spook a user out by showing all of these permissions. They want to show you just a few. Once again, you can drill in, most people don't. What you really get access to if you click on this app and click accept, back to single click compromise, is this app gets full access to read your email, gets access to write email, gets access to send email, it gets access to your chat, read all your chats, download your chats, chat as you, gets access to all your files. And if you were unlucky enough to click on this app as an administrator for your Azure Office 365 organization, it has full access to that as well. So, when we talk about complexity being the enemy of computer security, not so much the complexity per se, but it's how we try to gloss over that complexity for our end users, for our systems administrators, giving them the illusion of simplicity in administering and their day-to-day computing activities is both a blessing and a curse. It's a blessing because it makes our jobs easier. We can continue to function, work our jobs, work in email, work on documents, live, laugh, love. But it also can make things easier to make mistakes. It also makes it easier for an attacker to gain access and take advantage of that complexity simply by understanding the complexity at a layer greater than the administrators of that particular organization. That's where the danger lies. So let's talk about that complexity, simplicity example. Other things that we can do to take advantage of that is if we want to do things like password sprays, we can utilize as an attacking company in our legitimate pen test, we can utilize a service like Amazon to attack a service like Microsoft for a password spray. And we can use tools like Fireprox, which will allow us to rotate our IP address, and it'll utilize Amazon's API gateways to rotate through the request through different IP addresses every single time a request is sent. So trying to detect a password spray from a single IP address becomes exceedingly difficult. Trying to block becomes even harder because a lot of these cloud providers don't want to block each other because they're afraid of shutting each other down. I want to tell you a little bit about one of my favorite places in the world. I haven't been to Vegas in a long time, and I don't really miss Vegas at all. But there's this one place in Vegas, Batistas Hole in the Wall. It's an amazing Italian restaurant. And at Batistas, you can see the menu on the wall there. They have amazing Italian food. Prices are great. And with every purchase, you get all you can eat table wine and bread, garlic bread, like white and red wine, as much as you want to drink. There's one of the last places in Vegas that's like that. There's this guy that walks around. This guy right here, his name is Gordy. He's an accordion player. And as near as I can tell, Gordy is a vampire. I've been going to Batistas Hole in the Wall for 20 years, and Gordy has always looked like this. Further, I've never seen Gordy in sunlight, to be honest. Gordy just walks around with that accordion around his neck, and he'll go up to a table and he'll say, "Do you have any requests? Can I play a song for you?" And you'll make a request, and he'll be like, "I've got one for you. I got the perfect song for you." And then he'll play "Take me out to the ball game, regardless of what you requested. And then you'll tip him and you'll laugh heartily. And then Gordy will go to the next table and he'll do the exact same thing again. I love Gordy. I love Batistas' hole in the wall. And this particular attack is important because of accordions. So you see, Amazon makes it easy for you to deploy very complicated stacks. So if you wanted to deploy a full elastic map reduced stack, you'd have to install something like 15 different technologies and get them all to work with each other. And that is complicated. And Amazon wants to make that easier for you to deploy an EMR stack. And elastic map reduce is for large data sets. Now, with Amazon, you can do that one-click deploy and bam, it's deployed for you. And you think Amazon deployed it, so therefore it must be secure. But in this example, it'll show you that that's not necessarily the truth, because we get to that complexity and simplicity kind of disconnect. You're deploying something that's highly complex, and you're deploying it with one click. That's just rife with all kinds of problems. One of the problems that was discovered by one of our testers at Black Hills Information Security, Jordan. Jordan discovered, and he wrote a blog post in the lower right-hand corner, that whenever somebody has an EMR stack, which is a collection of technologies, it's a lot like an accordion. As the demand and the processing goes up, it'll start building up the components of the stack and duplicating them to meet demand, and it'll decrease those components when they're not needed. Think of Netflix. As Netflix demand in the evening goes up, it's going to need more servers, it's going to need more services, it's going to need more bandwidth, and they can scale in the cloud as needed, and then they can scale back down when they're not needed, like an accordion. It gets bigger and it gets smaller. However, what Jordan discovered in this example is one of the components is something called Hue. And with Hue, you can configure it, lock it down, secure it. But as Amazon starts extending it and bringing up more Hue components, it copies the technical components to make that Hue interface work properly, but it doesn't copy the security configuration. So as it stacks up more Hue components on top of each other, all of those ones that expand out are running at their default security state. And on that, it says right here, since this is your first time logging in, pick any username and password. Be sure to remember it, because that will become your default user ID and passwords for this Hue instance. Once you're in Hue, you can upload shell scripts, you can execute shell scripts, you can schedule shell scripts. It gives you full access to that full elastic map reduce stack. And that shows you once again how that one-click deploy is super simple in the cloud, but you're actually doing a lot of complex things underneath the hood, and attackers can take advantage of that very easily. Also, a closing thought. We're talking about the cloud. It's an abstract thing, right? You have Amazon, you have Google, big data centers doing all kinds of big data center-y things. It's small. My kids use this plugin in their browser called Grammarly. Whenever they write papers or anything, Grammarly is constantly checking their spelling and their grammar. It'll underline it in red, and you can right-click it, and Grammarly will give you recommendations on how to fix the grammar and the verb tense and the spelling. Make no mistake, Grammarly is a keylogger, logging everything you type in the browser and every single tab that you type it into, and it's sending it up to the cloud. The browser is truly the new endpoint, and the data that we access is in the cloud. So when we're thinking about cloud computing, we can't just think about Google, can't just think about Amazon, can't just think about Azure. We need to be looking at remote management into our environments. We need to be looking at browser plugins on every single workstation that accesses our data on the cloud. And this is a good thing, a very good thing for us in security. And the reason why it's a good thing is you're going to have a job for a long, long, long time. Security is not solved. Complexity is not decreasing, and the problems aren't going away. So thank you so much for attending the Security Weekly Unlocked event. Sorry I couldn't see you in person. We're going to fix that next year. So thank you so much. Have a great day and stay safe.